All right, hey there. Welcome to Programming through Mobile App Development, Websites, Servers, and Remote Access. So, coming up in this segment, we're going to talk about web pages again, briefly, discuss how internet traffic and servers work into the equation, discuss a little bit about website structure, how files and links should be structured. Maybe not should be, but the difference between those structures. And remote access. So how do we even do any of this stuff from our home computers, right? So first, what is a web page? And is it an app? So web pages are the basic documents of the internet, right? Everything that you find, everything you go to online in a web browser, right, is a web page, right? So anything made to display in a web browser. So anything you've ever searched on Google, every time you log into Brightspace, every YouTube video you pull up, as long as it's in the browser, those are all different web pages, right? They're the content of the internet, and they're typically composed of the three web dev languages: HTML, CSS, and JavaScript. Those are not the only ones, but that is what is primarily any old web page will probably have some of each of those. So what is the structure of a web page, right? And it comes down to the languages, right? So HTML is the hypertext markup language, and that is the basic elements that you see on the page and their structure, how they are nested, how they're connected to each other, where the headers and images and all the different kinds of things that you might see on a page, right? Or the video elements on YouTube, for example. That is a simple HTML5 element at this point. CSS, which is the cascading style sheets, and this is how you adjust all the parameters of the elements and change how they look, how they are positioned, all that kind of stuff. And then finally, JavaScript, which is all of the interactions on the page, both behind the scenes and with the user. We're going to have refreshers on each of these moving forward into the course. So, simple HTML only web pages exist, right? So you can build a web page that is just HTML. In fact, a lot of faculty members have that kind of web page. You might find. Look around. So when it's just HTML, all the elements are present and the relative structure is defined, right? So headings are coming before the header, before the body text here. We have some links at the top and the bottom. They're not just sort of randomly strewn about. There's a search bar included with the navigation items, right? So these are all intentional decisions that somebody who wrote the HTML here decided, right? They wanted their structure to be header stuff at the top with some links and navigation stuff and searching. We have the main text of the page, and then we have at the bottom some other links, right? So all of the elements displayed here in this example are the default properties as determined by the web browser, right? There is no styling done here. This is just if I write, hey, web browser in HTML, I want this element. Well, that's what the first header looks like. That's what the second header looks like. That's what the subsection header looks like. All that. So it's all basic stuff, right? So the browser will make decisions for you about what the HTML should be presenting, right? So it's a basic font, and headings are bold. Everything else is left aligned. The padding, there's a little bit of padding and margins between the elements, right? So like the paragraph is a little bit separate from the heading. Those are both properties of that element. Bullets are listed vertically, not sideways. Okay. So now let's just talk about ramping this up a little bit. Once you add CSS into the mix, now we've got the exact same page with an additional subsection that I had to remove on the last one. The exact same page now with all the same elements, right? But now look how they're completely rearranged. And this is just adding CSS, right? We didn't do any tricks with any like scripts trying to move things around. This is just saying, hey, I want the display properties of all of these same items to be different. So the fonts have all changed, the locations have changed of all the elements, the body text is a bit different, and the header links, those in particular, have been like totally reimagined as a navigation bar, right? They used to just be a bulleted list, and now they are a set of links displaying at the top, right? So we have added a huge amount of usability to this, right? As opposed to just scrolling top to bottom, we now have like distinct regions of the screen that are useful for different things, right? So you keep going, keep adding. So now we can add some interactivity, right? So this is where JavaScript enters the equation. So this, let's see, is it playing yet? Okay, yeah. So this clip is Google's basic site. So there is a title image, there's a search bar, a couple of links at the top. But the instant I have clicked into the search bar, it jumps out with a whole bunch of new elements immediately. So as soon as you click that, this drop down pops up with all these options from different trending things. So now I start typing in search terms and everything on the page changes. Everything in that drop down changes to be more things that it's pulled from their servers as better suggestions. I am here searching for cute photos of capybaras. And then finally I hit enter and the search executes and we leave the page and we move on to the images page, right? So we did leave that page, but the point is that there was a lot of interaction going on in just that, that upfront, just a simple Google page, right? And that was all dynamic. It was all interactivity. It was the ability for the page to do things in response to me doing things on the page. So that brings us to this concept of, why are we talking about web pages? What is this about? I'm not just building a website here. Yeah, well, the point is that those are also apps, right? In the broad sense that any amount of interactivity toward a specific purpose, that becomes an app in a sense. So there are static web pages, right? So the kind that we first saw, the HTML web page, those are really just about displaying information and maybe helping you navigate a little bit. Not much of an app, but still a small amount of interactivity. Then we have things like single page web apps, which is more about doing a specific individual task. So Google Calculator, just the word calculator in Google search bar, and it'll pop up a tiny app that's all right on the web page. You can see the example here. And it functions, right? It's a bunch of clickable buttons. They do math for you. That's a little tiny single page web app. It's even smaller than a single page because it's just like one of many things on the page. But the idea here is that this is a single purpose, single page web app. Then we get into things that are like maybe multi-page web apps, which is, a whole website built around a specific type of interaction. These are your, all of Google's pages are aimed at sort of helping you search for different kinds of things, right? Facebook is another, multi-page web app, right? It's like you have all your different feeds and your different, your own page, your friends' pages, but they're all sort of within the same we are socializing thing. I gotta stop using Facebook as an example. They suck. In short, a web page is a way of presenting information to the viewer that they can typically interact with in some way, or to bring back the definition in this course, that's an app, right? That is a interactable piece of software, and it just happens to be running in a browser. So, quick recap on web pages. Web pages are the content that people go to the internet for, right? Text information, images, videos, audio, all that kind of stuff. They can be a simple static web page that's just like mostly for informational purposes, or they can start mixing in interactivity and become more of a single or multi-page web app designed to do certain things that a user might be interested in doing, right? They're primarily composed of the 3 web dev languages we'll cover in the rest of the course, which is HTML, CSS, and JavaScript. And one little additional secret, this is all just text documents full of instructions for how the browser should display things. It's all text. Apart from media files that you'd have to store separately, but all the code, all the HTML, all the CSS, all the JavaScript, they used to be blank text files and then they became fully written text files. So that's something that I'm going to harp on a lot. It's just text. It came from humans typing. Well, Mostly humans. These days there are weird tools out there that automate some of this. Don't rely on those. Okay. How exactly do we wind up being able to view web pages? So, I'm over here and you're telling me that Google is somewhere in California. What's the deal there? Obviously, I'm just talking about the internet, right? But the question is, how do we get to and from different pages? What's going on? So we all use the internet all the time, right? That's the basic fact of life at this point. And we basically understand that somehow or another, when I send something out, it has to go across the internet to reach its destination. And that can involve a lot of in-between steps. But we can talk about a little bit simplified version for how basic websites function in this. And the things that we're going to talk about that connect to that are IP addresses, domain names and domain name servers, and then web server software. These are all the things that are required for your web browser to be able to get a web page from somewhere. So let's talk IP addresses. How can my computer talk to another computer? So your computer, your phone, whatever you're using, your device, it does a lot of things locally, right? It can save a document to the local hard drive and then open it up again later. But we also know that Google doesn't live on our phones. It's out there somewhere online. So the question is, how do we find it? And the fundamental way that IP addresses work is they are the literal, kind of like your own address, right? Where you live to receive mail, right? So the basic way to get from one machine, one system, one device to another system, machine, or device, right? It's out there somewhere, and I need to find it. You use addresses. So this is the IP address, the Internet Protocol address. There's those 4 numbers separated by dots that specify your unique location on the internet. Now, that doesn't mean your physical location. No, IP addresses are not tied to your physical address. It's just a specific number, right? And if someone wants to come knocking on your computer, then they will type in your number somewhere. And every computer connected to the internet has one of these. Now, before you get spooked, by default, your computer will reject all requests. You have to explicitly open it up to be able to accept requests. By example, Google's IP addresses that it has secured for itself are 8.8.8.8 or 8.8.4.4. Now, you can't just type those in and expect to get connected. They use an entire complex system that interacts only with other elements. But that's the idea, right? So this concept, this address, your computer has it somewhere, and you could essentially set everything up to just be addresses seeking other addresses, right? My computer needs to go find this IP address. Now, that would be pretty unwieldy, wouldn't it? So now we get into domain names, the .coms and the .nets of the world. So IP addresses would be cumbersome to just use all the time. Can you imagine if every time a podcast directed you to their website, they had to drone off a list of numbers that you had to memorize and type perfectly into your web browser, right? That would not be a good way for the internet to function. So instead, we made this method so that humans could actually remember any of this, and that is domain names. Google.com is a domain name. Com is the top level domain, which is just the suffix there. Google is the one that they have purchased for themselves or reserved or whatever. They probably don't pay at this point. I don't know. Who would they even pay? They are the internet. Oswego.edu is another domain name. It is a reserved chunk. The .edu top level domain is pretty much reserved for actual schools, like accredited schools. So Oswego is among them. So this is the idea. You don't want to just set up a computer with an IP address and say, hey, everybody, memorize this IP address, and then that's my website, right? You want a domain name, because otherwise it would be too cumbersome to communicate. So yeah, typically what ends up happening is we end up renting space on a domain name server in the form of these domain names, right? Okay, so I have an IP address for my website. I have a domain name. Now, how does that work? But a quick aside, URL. This is called the Uniform Resource Locator. This is that big address that you type into the bar, right? Into the address bar at the top of any browser. You would type usually just the domain name, because something else will handle the rest, but you can see how it changes all the time, right? So these are uniform resource locators. This is essentially whenever you do that whole link to some specific page online, it uses this same exact syntax, right? So that's why it says uniform, and resource locator is just hey web browser, what exactly are you trying to find, right? So my site here has the URL at Oswego, https://cs.oswego.edu/JKL/. So that contains the domain name cs.oswego.edu. Oswego.edu is the main domain. CS is our little subdomain in the computer science department. And then from there, on the left-hand side, we have the protocol, which we'll talk about later. And on the right-hand side, we have my specific set of folders, my specific set of files that are on that CS Oswego server. So URLs are going to contain both the domain name as well as the location of the specific web page requested. In the example there, we see VeriSign domain names, the online index, right? So that means that their index is in the folder domain names, and then the folder .online, and then the index.xhtml is right there. And this is the most common form of link, right? Anytime you are sending a link to someone else to hey, click on this thing. Hey, I found this thing. You should read this article, whatever. That is a URL. So just quick aside so that we don't get it twisted. Domain name is not the exact same as URL. It's actually part of all URLs. Okay. So now domain name servers. These are essentially the traffic signals of the internet. So how are domain names managed? Well, so there are established DNSs, so domain name servers out there, that keep track of which names point to which IP addresses, right? So if I have purchased a name and I want my computer, my server, my whatever is holding my website, I want to point people at it using this domain name that I've got. Well, that's how you get registered on these DNSs. So it's basically a gigantic phone book, right? It's a huge directory of, here's a name, and then here is the IP address that name points to. Cool. So when a request comes in from a web browser for a specific domain name, the DNS says, okay, let me go look for that. Okay, here's the actual IP address. So I'm going to send your request forward. I'm going to send it onward. Holding space on these servers costs a nominal fee. It's small-ish, but it does depend on what you're trying to do. Some of them cost $2 a month. Others cost $2,000 a month, depending on what kind of if it's a super popular name, right? Like the website, I'm sure the domain name fun.com was an expensive one because it's simple, it's easy to remember, and it's something that a lot of people would just instantly memorize, right? Whereas my last domain that I have, it's actually lapsed by now. It was like drjkl.xyz, which it's a little weird. It's clunky. You have to explain the XYZ to people. That was like $2 a month or something. So that's the quick aside on if you want to buy a domain name, you're going to have to figure out, how professional do I want mine to look with a .com, or do I want like a .me or a there's a lot of dots. It's crazy. Okay. So now we're getting to, so we understand now when I look for when my browser says I'm going to go to a web page, and then it sends the request out. It goes to the DNS and says, hey, here is this domain. Can you find the page on that domain? So the DNS says, okay, let me see. Here's the correct IP address. I'm going to go knock. So yeah, it's forwarded the request to the target IP address. What's next? So the system connected at the IP address needs to be running some sort of web server software for that request to mean anything, right? If you find out my IP address of my phone right now, or of my home computer, I don't have a web server software running on that home computer. So the network would just be like, what are you talking about, right? Speaking of web server software, are things like Apache or Express. So Apache is the kind of the standard, right? Any computer can install Apache and start running it. You have to do a little bit of finagling with your router to make sure it's accepting and forwarding port requests. But if you run Apache on your computer, your computer becomes a web server, essentially. So as long as a web server is running on a machine at a specific IP address that it's accepting requests, now, that web server just sits there waiting. It runs up, it starts up, and it just sits there doing nothing until someone makes a request. So when the request comes in from the browser, from the DNS actually, from the browser by way of the DNS, it receives it and it decodes the request to figure out, okay, what web page are they actually looking for? And specifically, it's going to send the code of that web page back to your browser, right? By default, it'll default to the main index page, right? So if you go to google.com, it doesn't look like it has like a file associated with it, right? But really, secretly it's just the page index.html that it's automatically loaded. So by default it would be that main index page, but it can really be anything that the web server software has access to, right? So normally the web server will only have access to a certain subset of folders. We'll see that in some of the demos later. But now, okay, so let's say I have successfully asked for a page that it wants to make available to people making web requests. So now it sends it home, right? So that information comes back home to your web browser. The web server sends it back all the way down the pipeline back to your web browser, right? Your web browser sent out this request in the form of an address, and some distant web server out there in the world heard that request, gathered up the contents requested, and sent them back your way. Now your browser can just render it. Your browser is explicitly designed to run HTML, CSS, and JavaScript code, and it renders it. And it's essentially like you have downloaded the entire program, right? The app, the thing that you are working with has just come right into your web browser, right? It's not still out there somewhere. The transaction has essentially completed. So when you load a web page, you copy it from the source and then run your own version of it in your browser. Yay. And that's the full loop. You need to understand that basic, how does this internet traffic stuff work, so that you can understand what is possible and what is not. Okay, so let's walk through an example again. How your data moves through the internet. And it's a little simplified. There are oftentimes other steps, and sometimes there are proxies involved and that kind of stuff. But for now, say you want to access Google, right? You go to the google.com domain name. Your web browser, you can type that address at the top, or click that link that's here in this, if you're looking at the slides. Click that link. Your browser then connects to a DNS, so the domain name server, and it's like, okay, this domain name server is like, okay, google.com, I know that that's owned by this IP address, so I'm going to send it on. So then it goes to that specific IP address, and then, everything online has an IP address, and it asks for the code of the web page, usually the main index by default. That code is sent back over the internet, bouncing around until it reaches your computer. And again, to put this in perspective, that's all in like a quarter of a second, right? I go, hey, Google, and instantly it appears. Hope that snap wasn't too loud. It pops up quite quickly. So that is kind of the fundamentals of how a web browser can talk to another, can allow your computer to talk to another computer out there, right? And I hope that's sort of bringing to the forefront the idea that these are just two different computers, right? They are essentially the same beast doing just slightly different things. Websites aren't some ethereal mystery, I mean, more and more, I guess, as the cloud computing stuff kicks online, but they are a physical machine somewhere, right? And it would be the same process to connect my home computer to my work computer over the internet as it would be for me to connect my home computer to Google, right? So to recap, internet traffic in general. So to get to a web page full of information or interactions that we are after, the browser sends that request in the form of a human-readable domain name. A DNS then takes the domain name, finds the correct IP address, and sends it onward, and then the web server at the other end sends all the code back of a complete web page so that you can look at a cat photo or whatever. And since I have to include my cat in every class I teach, this is a little bit, she's cute, she likes to shrimp. Okay, so cool. We figured out a little bit about how, what are web pages, and it's like kind of lots of little tiny programs. Sometimes they're simple, sometimes they're complex. And then how do they connect online? Now let's talk about what exactly then is a website, right? And how is it structured, right? So websites are collections of interconnected web pages. We see that most web pages live somewhere together online in the form of servers behind domain names, right? So Google has a bunch of different pages under google.com. That's essentially what a website is, right? It's a collection of pages somewhere. The question, though, is like, it can't just be a pile of random pages, right? You have to have some kind of structure there. So, right, and there must be some sort of structure to how you are presenting these pages and how they are stored on the website. So let's spend some time to pull apart the difference between file structure, which is where the files live on the server, and link structure, which is how the files relate to each other and how your users are going to navigate your site. Okay, so file structure. This is how your web pages are stored, right? And look at this image on the right. It should be familiar. This is just basic files, right? Anytime you open Explorer on Windows or the Finder on Mac or etc., right? You have some kind of way to look at your file system, and it's just a bunch of folders, right? It's files in folders. So that's the same thing for websites, right? And as I've discussed before, again, it's just another computer. So web pages have to be stored somewhere and somehow, right? In this way, they're very similar to your own desktop computer. There is a file system, right, that uses directories, and also known as folders, to organize all the individual files that you have on your drive. Just how you might have a different folder for homework and one for movies or photos or whatever on your hard drive, that's the same way that a website could be constructed, right? So lots of different folders containing everything on the site. But the link structure is more about how web pages are functionally connected. So users almost never navigate websites by way of navigating a directory of folders, right? That would be a little arcane. That would be a little too down in the weeds, right? On a website, you want to be able to jump around to the things that are related to what you're interested in on the site, right? You noticed how in that video a little ways back, I searched for capybaras and then I skipped the text links. I jumped straight to the images, right? That's because the link structure was easy for me to navigate because the way of everything was structured on the screen. So this is how we interact with websites. We use their link structure, as in the navigation links we provide on each page for accessing other pages on the same site. This is how users really find their way around, right? You need to present links so that everything is clear for how you can move to the next page. Or maybe not, don't think of it as next, but the user's next page, the page the user is most interested in moving to next. And it does not have to match your file structure even a tiny bit if you don't want to. Let me show you a basic example of that. So, from CS server websites, for example, here is a file structure, right? One of the subfolders on this site is lab number 2. And in it, there is the index and then 3 tasks, right? they are all in the same folder, right? So the structure that we're seeing here is lab 2. There's an index, there's a task 1, task 2, and task 3, right? Here's a different structure. So this is the same kind of idea. It's just that we've used subfolders for the task. So now the file structure is different, right? We have a lot more folders involved. But here we go. So there's 3 separate folders, and each of the tasks has its own little index page, right? These are different file structures. But as you might be able to infer before we even move through this, these could very, very easily have identical link structures. Because, okay, obviously if I'm going to the lab 2 page, I'm probably going to hit the index first, and then that page will link to each of the other ones, right? It doesn't matter that they're in the same folder in this case. In fact, it doesn't matter if they're in different folders. Your links can point anywhere, right? Remember, links are just going to use URLs to pull up any old page anywhere else, right? So these are different file structures, but they are identical link structures. And that is the kind of thing you need to keep in mind when you are considering how your website functions, right? In the same light, let's consider Wikipedia. So you go to wikipedia.com. It's full of millions of web pages. They're all offering different information on a variety of concepts and ideas, right? But there's something kind of funny about it. When you look at the URLs, every single page on the wiki seems to be stored in the wiki folder, right? So wherever you access, whatever the root directory is on wikipedia.com's server, the wiki folder is first, and then everything else is some kind of, is another page, right, with its own index. So this is implying the structure that everything is just flat, right? It's one folder called wiki with a million web pages under it. Now, by the way, I just want to say, they probably have other tricks going on behind the scenes. They're probably using some databases. It's not just a bunch of web pages, right? But the apparent file structure from what we're able to see from the outside, right? So imagine if Wikipedia made you navigate it by scrolling through a nearly endless list of relevant information, or perhaps irrelevant information. That would be a dang nightmare, right? That file structure would not be an acceptable way to interact with this piece of software, this website designed to educate me on a variety of topics. The link structure, now that is so much different. That is so much more robust here. We know Wikipedia is really a knowledge base, and it's this interconnected collection of pages full of knowledge that all relate to one another. That relationship is and can be made a link. So this one page for capybaras contains links to a huge number of concepts, and we haven't even gotten past the first paragraph here, right? I mean, look, we've got South America. You can go learn about that. That is a relevant structure. A giant cavy rodent. I don't even know what cavy means. It's probably some sort of genus or something. It talks about guinea pigs, which are related to it, blah, 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 chinchillas. But then we can even go and see all the different, the taxonomy, you know, the kingdom, phylum, class, order, family, etc. It's hugely interconnected. This makes it so easy for me to jump to other relevant topics just from the one page, right? So yeah, the link structure here is in full bloom. You know, this is a knowledge base with semantic links between topics that are so easy to move between. So as your site scales up in complexity, you need an increasingly robust link structure to go along with it, right? Your site in, say, a course like this is going to just be sort of straightforward, and your link structure might follow closely the file structure, but just remember that the two are different. As an example, too, so this is just one visualization of a tiny fraction of the overall link structure of Wikipedia. And it's hard to see what's going on. Why did you show me this colorful ink blot, Professor? Well, each of these little dots is, you look at the bottom left, it's kind of zoomed in. It's the same image, it's just, so that's why it's kind of blurry. But these are each dots, right? And there are links between the dots. These are web pages. Every dot is a web page, and every link is a literal link. Like this page links to this page. I'm not pointing at anything. I know you can't see the mouse. So this is how interconnected these pages are compared to the flat single file folder thing. This is wildly different. And again, this is just a tiny fraction of the overall structure of Wikipedia. If you're wondering what you can pull from this, that's tricky. That'll come later in your degree. So when it comes to using these different structures, here's how you can kind of think about each one. File structures are really for you to organize the components of your website in a clean way. You can think about it the same way that you might organize your own files on your own computer, right? You have different files for projects, etc. So you might have a project, you might keep its images in one folder, its CSS files in another, your JavaScript files in another folder. And that's just one of many, many ways to organize things. Whatever makes sense for you when you are building your pages, it's all good. Just keep in mind that the link structure is really more important for the user side, right? You get to structure the files however you need to, but in the end, you need to keep track of your link structure too, because that's how any user will ever experience it. These are the questions that you might have for yourself when you think about, okay, how does my website look? What's the first page that a user should see when they enter your site? Probably some kind of landing page that helps them navigate, right? What should they have access to from that page? Is it everything, or do you want them to have, do you want one huge central hub page, or do you want lots of loosely connected sub pages with their own links that flow a little more naturally? The point is, it all depends. What are you trying to do with the site, right? Google has lots of different sub pages because it's trying to do a variety of things all under the same banner. But that's not necessarily what you always want. Sometimes you want everything up front. Just a question to answer for yourself when you are tinkering with these things. So, recap on website structure. Websites are the collections of web pages that live at a certain domain. Behind the scenes, the file structure can be whatever is easiest for you, the developer, to make sense of. But as far as the user experience is concerned, the link structure is far more important. Ultimately, it's also more powerful, right? Enabling users to navigate huge amounts of information in a fluid way just by following all the conceptually related links around your site. And ultimately, it doesn't matter at all how those files are stored on the disk. You just need to keep track of the links. Okay, next is, how do we access and develop these sites, right? I mean, I'm supposed to plug my laptop into the department server, or no? We use remote access tools. So how we can connect to servers to build, update, and maintain websites. So we've learned all about, how internet servers connect a bit and how websites should be structured. We're also supposed to access these things from our own computers, right? So how do we do that? The answer is remote access tools. These are basic tools that use the same mechanisms as web page access, IP addresses, web domains, and all that. But instead of just requesting the contents of a page to come back to me, they are requesting the ability to upload, copy, edit, and download files from the remote server. Now, you really have to have special access to these things. You can't... Google is never going to allow you to FTP into their servers, right? But the CS department server, yeah, it will be set up for you to do such things. So let's talk about FTP clients, File Transfer Protocol. So there's a few ways to connect to remote systems, but we're going to go with just focus on the more straightforward kind. FTP, File Transfer Protocol. Clients specifically. So these are tools that you download, you install on your computer. They're fast. They're usually very lightweight. They'll let you connect to a remote server, for example, the CS department server, and ta-da, you can transfer files between your local computer and the server. Once files are uploaded, provided they're in the place that the web server software can see them, then they're live on your website. You can make HTTP requests to them at that point. Right. So once you put a file up in a spot where a web server is running, that's a website, baby. That's how it goes. The one we would probably focus on using is called FileZilla. This is one of many, but it's the most straightforward. It's multi-platform. It's easy to install, and it runs cleanly. Quick tour of this. At the top is where you would connect. So you would type in. So the host would be the web domain, right? The partial URL that you're trying to connect to, cs.oswego.edu. And then the username would be whatever username you will have set up. That's something that will happen. And password, same idea. So the idea is you would click the connect button and it would send your credentials over along with the FTP request. And it would say, okay, you have access. Now you can start sending files or downloading files or whatever. So then just quickly, the two other main things you would want to see here are on the left side, those folders would be your local machine. It says local site there. And then on the right side, remote site would be the remote machine you're connecting to. Again, just two different file systems that you suddenly have created a bridge between, which is nice. It allows you to do web development. Wonderful. Now, another quick aside, because this is something that you should be aware of. I've used the term protocol a few times here. Let's talk about what protocols are. So HTTP, HTTPS, FTP, SFTP. That it's always in the URL, it's that first chunk before the colon, right? So HTTP : / and then you start your the web domain and then the specific files and stuff. So far, right, what we've seen in this course is two forms of web requests that a system can make. Regular web traffic to navigate to websites and download pages uses HTTP, or Hypertext Transfer Protocol, as in specifically for hypertext markdown language files, HTML. And then later everything else came along with that. But the original reason to have this protocol was to get the HTML of a web page that your browser could read it to you. HTTP is mostly one way. So you ask for the web page. Me from sitting here on Chrome, I ask for a web page. The page lands, and then that's the end of the transaction with the server, right? Obviously, there are other ways that you open up connections to the server again, but that's more complex and more JavaScripty stuff. The basic HTTP interaction is, hey, fetch me the web page. FTP, File Transfer Protocol, is two ways. So it's opening the door to both sending and receiving data, including files. So now, both of these are kinds of web requests using two different protocols. And something that you should know about them is that in their default state, they are super unsecure. They are just plain text, wide in the open. Anyone who cared to look could see the requests. Now, that doesn't mean that they see every single element of it and they see everything that you're going to see and all that stuff. But anytime your system connects to another one using HTTP or FTP, all your requests you're making can be examined by kind of anyone who is looking. Security is serious, right? And that's why I'm talking about this. But at the same time, I want to extend most people aren't looking. None of us are that interesting, right? And it's not all that interesting stuff. Besides, most things use what I'm about to talk about anyway. So if you see the letters HTTP and with no S or FTP with no S, then remember your interactions are plain text and you should be careful. This is why we now use encrypted versions of these same protocols. So really what we want are HTTPS, which is Hypertext Transfer Protocol Secure, and SFTP, which is Secure File Transfer Protocol. Essentially, look for those acronyms and try to use them all the time, right? If a site has just HTTP with no S, be careful. Make sure you trust it. But also, then don't send any credit card information over it or whatever. Because ultimately, while I don't think you should be afraid of the concept of individual people peeping on your stuff, you never know what algorithms are peeping on your stuff, right? There are web scrapers out there catching everything and doing weird stuff. You just don't feed the beast, Okay, so that is the idea. of protocols, but more specifically the idea of file transfer protocols. We're able to open up a connection to a remote place and do things to it. Add files, remove files, copy files, etc. Upload, download, great stuff. So let's talk about sort of the basic loop of web development. So, okay, we've got our server set up. Let's presume, right? Presume you have a space on a server somewhere. You've got your FTP client ready to go. You've got a text editor open, and you've already written your first HTML file that you wanna test it out, right? So if you want to see your web page in action that you are sitting down and writing, you have two options for opening that file. Open it locally in your web browser, and that should just pop right up there. Not too hard. You just, typically you can just double click it from the file loader, and it'll be like, oh, that's an HTML file. I'll open that in the browser. Or you can send it off to the server, and then it will actually be online, as long as it's in the right place on the server. It's a web page you can view. You can just, it'll be on the internet. So you can use the URL bar and find your page, right? Either way, the page typically works the same. There's a lot of exceptions once you get into more advanced stuff. But the point is that when you can do whatever you want to test this, but the only way that your page will be published is if you put it up on the remote server, and then, that's part of your website. Let's do a quick little back and forth on this. So checking out the process as we've seen it before already. So working remotely, here's your browser, and here is the CS department server on Apache, and it has a bunch of different web pages already up there, blah, 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 somewhere stored on it. To interact with this, for me to upload a file that I want to, be on my web server, be on my website, I would say, hey, I'm going to open an SFTP connection to Oswego. I'm going to give you my credentials, blah, blah, blah. And what I want to do is I want to send this file to this location. Home, JKL, public, HTML, index.html. This would be me editing the main page of my website, essentially. Okay, so assuming that we connect properly and the web server, the FTP server is like, okay, sure, come on in. Then we add our file. And now our file is up there on the remote server. Now to check it out, we would have to do the classic move that we've already discussed of, hey, internet, HTTPS, can you go to this domain and find me this web page? And the domain name server is like, sure. Okay, I found the IP address. I found the CS servers. Apache says, oh, cool. Okay, I'll send that index to you, right? That's a lot of steps. I want you to focus on two things here. Hold these two things in your mind. That's a lot of steps, and there's some extra fail points and some weirdness here. In terms of if you're just trying to edit a web page to see how it looks, right? But it's also not that many steps. It's pretty easy to get into the habit of doing this upload and check process. However, there is a big benefit to working remotely, or working locally. It is that it is a single step. I have the file, the index file. I can open it in my web browser. It uses just the protocol file, which is essentially look on my home system, and it brings the index right into itself, right? So remote working requires internet and a few extra steps, but actually publishes your work to your site so that it's public. Local is fast with no intermediate steps, and you won't be constantly publishing your bonehead mistakes for all to see, right? So both of these are good. Both of these are useful. If I'm just trying to tinker with something quickly, I will almost always work locally. I'll just pop the page I'm working on open in the browser. But if I'm trying to test something a little bit more robust and make sure it's looking correct to the outside world, I might switch to working with the remote version of it. So essentially, you're going to kind of balance the usage of these two things. For simple things, like most of the things in this course, it's easiest to just work locally, right? It's quick. It misses some features because it doesn't use a web server software at all, but it really gives you fast turnaround, and you make changes really quickly and almost, again, instantaneously. Then when you're ready to publish things to your website, that's when you upload your files using the FTP client. So get used to doing both. right? You're going to want to work quickly locally, and especially when you're going to do things that are going to explode a lot and look bad and all that kind of stuff when you're figuring things out. So but be ready to quickly upload things to the actual server and check those too, right? So if you want to learn this web dev stuff, you'll benefit from getting very comfortable moving files around remotely, right? Web dev is the ultimate remote work job. So, if that's what you're into, this is the right path. So, locally and remotely working, to send the information out into the world over the internet, we need, the most basic choice is file transfer protocol. It's the easy way for me to put something on a place that's not my home computer. Except actually you want the secure version, SFTP. Again, we'll have some tutorials on that stuff. FileZilla is the most straightforward FTP client, and it should cover all the bases for this course. If you want to do something else, go right ahead, especially if you're already sort of familiar with it. But if not, FileZilla is the one that I'll provide support for. You're going to want to work on things mostly locally, especially for this course. And really, anytime you're just trying to figure things out, debug things, explore things, kind of try different options and objects and stuff, it's nice to work locally and privately and quickly in that way. But then when you're ready to publish your work, you upload it to the server using SFTP on FileZilla. So, a lot to keep in mind. So, let's recap this one. The overall ideas that we covered here. Web pages are the basic currency of the internet. They might be simple or static or more complex and interactive. And you will be toying with all of those in between here in this course. We retrieve web pages using requests that go through a DNS to find the IP address at the end and fetch the code of those web pages, right? So that's the fundamental way that we interact with the internet in the most basic sense, right? I want to load a page. We now have traced the steps to get that page, yes? Because of the nature of making direct requests like this, it kind of matters less about the file structure of your website because they're not going to have access to that in terms of the user experience, right? And it's a bit more important about how your web pages link to each other, right? Because you can just jump from one to another. There's no gate. There's no traveling between the file structure. And then to start building and maintaining a site, you need to have a server or a small piece of one. You need to have a text editor to write your code in, a browser to test those pages out, and then the FTP client to publish them to your server when you're ready. So, more to come, obviously, but this is our segment on websites and servers and such. Okay, and as always, I'm going to leave you with a final thought. Pick one or two websites you're used to visiting. Analyze their URLs with the ideas from this lecture. Right? Try to identify at least the domain name, the protocol, and some of the file locations of pages you normally visit, if any. You might just stay on the surface. Also see if you can contrast the site's file structure and link structure based on what you see in the URLs. Do you notice any patterns or surprises? Something you might not have seen without the concepts of this lecture? All right, that's it. Take care.